heard about the MEMS design contest from Mr. Anton Klotz of Cadence. He sent me an email in late 2016 and he said that you're planning to have this contest in CDN Live. Are you interested? And I said, yeah.
So we've heard about the design contest thanks to an email from Coventor, who advertised for the contest. And we decided to join it because we wanted to do a MEMS project with the students, and it was a good opportunity to design MEMS and to work on a co-design of MEMS and electronic.
We had two motivations to enter this contest. One was that I wanted my students, Sally and Ren, to learn about the tools. Cadence tools, Coventor tools, and get familiar with X-FAB fabrication process.
Also very interesting to us participating in this contest because our research activity is about the design of heterogeneous multi-physics systems composed of MEMS and CMOS electronics.
On the MEMS design part, there is three master students from the first and second years of master that joined the project. They work on some small period of time in a row, and then we also got some help with a postdoc from Tunisia, who helped us in the final design. So the ESIEE students are more electrical guys, and the postdoc from Tunisia is a mechanical guy. And so we joined our effort on the MEMS part.
Our team has 4 members. Myself, Sally Ahmed, I'm a PhD student in the electrical engineering department, and also Ren, he's a PhD student. We are both supervised by Professor Hussein Fariborzi. We had a 4th member. She's an undergrad student in the University of Electronic Science and Technology in China. She will be joining KAUST actually next year. So yeah, all of us on the electrical engineering department.
The initial idea was to build ultra-low power circuits based on devices that are not traditional. We call them post-CMOS devices. And as I said, the goal is to move toward ultra-low power, which is basically the main requirement for the IoT era.
The idea of the project came up when we received the proposal from Coventor, and it's based on, it's very strongly related to what we are doing as a researcher. So we decided to work on a vibration energy harvester that could be used at relatively high frequency to be compatible with the MEMS design, and with application, for instance, in an airplane to measure to provide energy to sensors that could measure some parameters in the plane.
So for myself, I didn't know actually the Coventor software, MEMS Plus, so I learned that. Ren already knew that, so basically I was learning that from the tutorial, and he was also helping me. It was also interesting to have a MEMS structure and do the layout in Cadence. I think that's the first time, so it was pretty interesting for us, and see like an industrial level fabrication and packaging, everything. Yeah, it was pretty interesting.
The tool we mostly use for the MEMS design is MEMS Plus, of course. So we use the graphical interface for building the 3D system. And then I really appreciate to use the MATLAB scripting for implementing various simulations, because you don't have to look in the interface where to find the good parameters to be changed. You just have to do it on the script, run the script again, and you have your new simulations quite quickly. And that was very time-saving way of working compared to maybe previous release of that software.
The main challenge was to connect all the dots. There were different tools, and process that the design needed to be compatible with that process. So just make sure that these tools are, I mean, the output of one tool can be used as an input to the other tool. So basically for Coventor and Cadence, and then from Cadence to layout, and layout be compatible with the ESIEE process. These were the main challenges that we were facing with. Right?
The main challenge was to minimize the leakage of diodes and minimize parasitic capacitances, which are always present on integrated circuit, and which are difficult to foresee, to predict in advance.
Yeah, I think, yeah, so basically, I think so there are some design rules that we need to follow. So we get some errors at the beginning, but then by learning again, we fix them. So it's just a learning process, yeah.
So we were of course very happy to win that competition, very happy for our students, very happy also personally because we have invested quite a lot of time in the project, so it's a kind of appreciated reward. And I think also the school, our two universities are quite proud of our students and about the project results. So that's just a lot of benefits for us.
I think it's one of the wonderful things that happened to us actually. So that's the first competition with with these big names, X-FAB, Cadence, and Coventor, and being a winner, of course, that means a lot of us. And being at the top 3, that's just amazing for us. And I think it will be good also for our future and our CV. Yeah.
I personally was happy, and I was happy to be a part of the winning team, and I was surprised.
I think also the competition stuff, the way it's designed, learning a lot of softwares, yeah, I just like it. Like we benefit, and also they benefit a lot from our feedback. So it was a great opportunity.
So it began as a competition for us, and then eventually it became a learning process, very involved learning process, and kind of a collaboration. We got a lot of help from the sponsors of the competition, and I'm happy that my students are totally educated now.